I'm going to talk about wine, metadata, and cheese, and what do they have in common. So at first, I will show you this picture, and this is the wine label, and this is a really nice example of metadata record, because in the metadata, basically, this is the set of properties that tells us the important thing about the resource. So in this case, resource is the wine, the product, and the metadata, it's written on its label, and it contains some properties, some information like the name of the producer, the special designation of the wine, the year in which it was harvested, the grapes were harvested, where it was bottled, how it was bottled, what is the type of the wine. This is Cabernet Sauvignon, the grape variety, what is some fanciful name, which may be some alternate identifier. Where is the vineyard? What's the name of the vineyard? What's the origin of the grapes? And what is the alcohol content? This may be some qualitative property in this case. And what does it serve for? So basically, this wine label is some information for the users which are seeking to buy some good wine, and they seek for some special characteristics, so they can see it here on the label. So basically, the wine label helps the wine users to find what they are looking for. So it makes the wine more discoverable for the users, and the users may filter through some of the properties. And this is everything we need from metadata. So basically, this is the really good example of metadata usage. How do we use metadata in IT or in the digital world? We have few reasons. Same as in the case of the wine, we need to find something or discover something we didn't know. We may also filter from the results based on the property values we seek for. Basically, what is the difference between find and discover? It is the case that when we are finding something, we are looking for something, we know it exists and it's there. And discovering means that we are looking for something we are not really sure what it is, but we can find it through some system. And the system in the case of metadata is a catalog. Basically, you can share the metadata records in some catalogs, and those catalogs serves us as the discoverable function. It is the discoverable function. I can look there and I can go through the metadata records to find something or discover something I didn't know before. I can use some filters according to some topics, themes, and this kind of stuff. So the main topic of catalogs is to make metadata discoverable on the internet. Which metadata to use? We have quite a lot of metadata profiles, and the main reason we have a lot of profiles is that we have a lot of use cases for the metadata. So for metadata states the same sentence like for any other tool. We need to have the right tool that helps us to do the job the best. You can see on the picture on the right that this hammer is not a drill. The same stays for the metadata profiles. So if you want to publish metadata about geospatial information, you are not going to use the datasite profile because it doesn't help you in any way. I just want to go through a few of the most used, in my case, in my opinion, most used metadata profiles, which differs in a lot of ways. So we use this as a demonstration or some examples. We are going to go through 3 metadata profiles. The first on the left is ISO 19139 family that states for the spatial data and services. This is the technical committee or technical group by ISO, which focuses on the spatial information, and they have created quite large, quite big metadata profile for spatial information. Then we have DataSite. This is one of the most used metadata profiles globally. It serves basically for description of scientific data. And the main purpose of the DataSite profile is citing of those data. And then we have DCAT AP, which is application profile created by European Union for the DCAT vocabulary. And it serves for discoverability of high-value datasets in the European data portals, and in the Czech scope, it also serves for the provision of and discoverability of open data. So we have those three profiles, and they differ in quite a lot of ways. So we can go through some of the examples and look what to do with it. So ISO TS 191.39/1 from 2017. This is the up-to-date version of the standard for geographic information, which is based on the XML schemas implementation. Basically, what does it serve for is for discovering of spatial data across Europe. On the left side, we can see the INSPIRE metadata profile. INSPIRE, as you may already know, is the European directive for sharing spatial information about environment. We can see on this metadata, in this metadata catalog, INSPIRE GeoPortal is nothing else than the metadata catalog. Sorry. We can see that we have the INSPIRE thematic data, and we can also browse through the high-value datasets, which is the new directive, quite new directive from the European Union, which uses the same metadata profile and the same catalogs. So it's also visible. On the right side, we can see the national metadata profile of the Czech Republic, which is also discoverable and browsable through the GeoPortal. As you can see, the INSPIRE European GeoPortal looks a little bit more modern and responsive than the web on the other side. Just to make a little bit sorry about the GeoPortal, Czech GeoPortal, I can say that it's really outdated, and the support is no longer provided, and nowadays they are thinking about creating the new GeoPortal. The bad stuff is that it is provided and managed by Xenia, and the Xenia may be cancelled in autumn. So they don't want to know. They don't want to do anything new until they know if they persist or not. In metadata profile of ISO for spatial data, we have a few properties, and I'm just mentioning a few of them for the reason that in other metadata profiles, we will meet similar properties, but maybe with some different meanings. So this is why I chose this set. From obligatory properties, we need to have some unique identifier. We also need to know who is responsible for the dataset. If I compare it with the wine label, the object identification is the unique name of the wine. The contact is who created the wine, who is the winer or winekeeper. Date stamp is here is the date of the metadata or the resource the metadata describes. In the wine label, the date stamp is the date when the grapes were harvested. So basically, this is the date of the origin of the resource. And then we have some identification info. Actually, in the XML schema, the identification info is quite complex type that consists of much more information. But basically, we can say it's basic information about the data, including date, the title, the date of the resource, abstract, and other optional properties. Then we have some more optional properties, like the language of the metadata, hierarchy level, which means that if we may have some resources which are related to the resource we are describing, and they may be related in hierarchical way, mostly. Then we can describe the metadata standard. It could be said that we are using the ISO profile, which is the metadata standard, but it allows us to extend it. So we can just link the metadata to the extended metadata standard, which comes from the ISO 19139 profile. And two more important properties is the distribution, which basically says where can we access the data itself, and the data quality, which means how the data set was acquired and in which way and how precise it can be, which is also quite important if you are looking for precise metadata, if you are looking for the precise data, because you are, I don't know, if you are planning the way from by the car from point A to the point B, you need the different precision than if you are building the house. Yeah, so it's quite sad. And this is how it's represented in a way. The metadata properties are represented in a way of XML file, which is quite talky, and it looks something like this. It's based on the XML schema definition file. I believe that all of you have seen a lot of XML files, so I'm not going into any detail here. It's not important for this way. And here is how it can be used, because we are looking on the ways how to use the metadata. So in this case, this is the result for filtering all of the European spatial metadata filtered by the team addresses, which is a keyword from the controlled vocabulary of the Inspire teams. And on the picture, we can see the results in the map. We can see that we have some sum of metadata records, downloadable data sets, viewable data sets, and also we have selected it by the country, because some of the data sets are national, some of them are global or regional. So this is what can we find. We can filter through the outputs in the more detail, but it's not really important for the case of this presentation. The second metadata profile is DataSite. It's one of the most used metadata profiles globally. I think it's the second most used metadata profile. And it serves for the publication and citation of research data or other research outputs. The data site, it's at the same time a non-profit organization. It's a provider of the OY identifier. And it's also author of the data site metadata schema, which is what I'm talking about in this presentation. And this metadata schema, the main purpose of the metadata schema is the citation. And it's also written in the documentation, and it's for me, it's really important that it is not intended to supply or replace discipline or community-specific metadata, which fully describes the resource. It basically means that if you want to share your data in the scientific world, you keep the metadata, you are using it for like before. So for example, if you are creating the spatial data respecting the Inspire directive, you will use the ISO metadata profile. And if you want to share it in the scientific world, you will add another metadata record, which will respect the data site metadata schema. Because it has another purpose, and it does not describe the resource in the same way and for the same purpose. So it have the different metadata properties. The current version is 4.5, which is really new. It's like 2 or 3 months old. But the difference between the older version is not really big. Let's go to the properties. The datasite profile, it has identifier in the form of DOI, and this is mandatory. That it may be quite a problem because not all resources have DOI. Another thing is that this identifier identifies the resource, the metadata. The metadata itself does not have any identifier, which may become a problem if you are trying to transform it or map it to another profile. Basically, if you are trying to create a linked data or linked metadata from that. The other properties are quite common. We are interested in who is the creator of the resource, what is the name of the resource, who holds or publishes or do something else with the resource. For example, in the scientific world, we may have some scientists that create the data, and then we have the institution which runs the portal for the sharing of the data. So those are two different institutions or two different persons. So we need to fill two different properties for them because both are important. Then we have the year when the resource was or will be made public available. This is also some specific stuff of the scientific data because quite often it happens that they gather some data and they are using it for the research. And the scientists, they are keeping the data private for the time they are doing the research. And they publish it after the research is done, so after some period. So that makes it the publication year maybe in the future for this. When we are working with open data or geospatial data, which are meant to be made public and to make users use them, this is something very different from this approach. And the last property is some description of the resource. Datasite is also an XML metadata profile provided by some XSD file. This is basically what I showed you in the last slide. And one of the outputs or the purposes of the datasite profile is to create automatically this kind of citations from the metadata. So I think this is something all of you know. When you are writing papers, you are creating the citations like this. So it may be done automatically for the data which are covered by the datasite profiles. And last one is the GetIP. Sorry for the quality of the picture on the right side, but this is the best I got. It has no official logo or something like that. So this is just something I found at the European Commission website. The DCAT application profile is made for sharing information about the data catalogues in the European Union. It was created by the European Commission, by the CIMIC EU. And it was created to support discoverability and the reuse of public sector information around 2010. It is obligatory to use for the high-value datasets, and in national level, on the national level, there may be some obligations coming from the national legislation. In the case of Czech Republic, it's open data. For the open data, we really need to publish the data covered by metadata in the extension of DCAT AP, which is called DCAT APCZ. Which guides me to another point that it is extensible. So there is a lot of extensions coming from the DCAT AP. We have GeoDCAT AP, which is made for spatial data. We have StatDCAT AP, which is made for statistical data. SiteDCAT is some draft version of conversion between DataCite and DCAT. And we have this Czech version of dcat AP, which is called dcat APCZ, etc. We have quite a lot of profiles. It's based on the linked data vocabularies and ontologies, conceptual vocabularies, mostly DC terms, but it reuses quite a lot of other vocabularies like friend of a friend and this kind of stuff. We have few metadata classes. The main ones, in my opinion, are the catalog, which represents the catalog itself. Oppositely from the previous profiles, the dcat also describes the catalog itself. So you can create a catalog in the language of the metadata. And we can create the dataset records. The new, really new class, which was set in February this year, is dataset series, which is something which can group datasets together. Then we have another class which is called distribution, which is the physical embodiment of the dataset. Basically, it tells us how to access the resource, the data directly. And we have the data service, which is a special case of distribution. We do not get directly to the data files, but we are accessing them through some data service, which is something you can imagine quite easy, I think. This is the schema, the basic schema of the dcat profile. I wasn't telling some special properties, but basically we have the same. In the data set, we have the title, we have the description, we have some recommended contact information and the topics. And then based on the characteristic of the resource, we can use some other properties like spatial resolution, temporal resolution, some references to other resources, versioning, some land pages. The same goes for distribution. Uh, Distribution has only one mandatory property, which is the access URL. Basically, this is the URL address where we can access the data. The same goes for the service, which doesn't have the access URL but endpoint of the service, and we can describe other properties. And it is provided in JSON LD. So this is the JSON LD representation of the metadata. And this is how is it used for. So this is example of the dcat AP catalog. This is the National Catalog of Open Data of the Czech Republic. So we can just get some information about the data sets and access it directly through the distributions. And the last topic here is the mappings. So in some cases, we need to transform the metadata between those profiles. So we have the ISO to dcat AP. This is done by the extension called GeoDcat AP. We have this similar extension to transform metadata from datasite to dcat AP, which is called site dcat AP. And we also have some kind of transformation between ISO and datasite, but it does not really exist in any official way. So I will come to that later. So the GeoDcat AP, this is some extension of the dcat AP profile, which supports Inspire metadata profile support and also the mapping into the ISO 191.15. This is the profile for the data sets, spatial data sets, but it has some cons. The biggest problems are with the versioning of the profiles they are extending. So the dcat AP, it comes from the older versions of both ISO standard and dcat AP profile. So that's basically it. The site dcat also includes the XSL transformation file, which is nice because you can just use it to transform the metadata. It has two profiles. One of them supports all of the datasite metadata that are supported by dcat AP, and the extended supports also those which are not supported by the Git API by using another semantic web vocabularies. The cons is also that it's meant as a draft and it's considered unstable. And also it uses the older versions of the profiles, both the Get API and data site. Another con for the site DGET is that it requires a DOI identifier, and also that the data site metadata, I also mentioned it, already mentioned it, they have no identifier of the metadata itself. The metadata identifier is DOI, which is all the time connected to the resource. And then we have something which we call mapping between ISO and data site. And I have found some transformations, but they were leading the other way, which means from data site to ISO. But further thinking about it, I think that it's not really needed because both ISO and data site have different usage and different purposes. And if I want to publish it publicly, I would rather transform each of them into the DCAT API than from one to another. And same as before, the main problem is that the data site needs an DOI identifier for the dataset, which ISO metadata does not have most of the time. And okay, what are the outputs of the presentation? So one of the most important things is that we need to use the metadata profile that fits the purpose we are looking for with our data. So we can imagine it like this puzzle on the right side, that if you have a circle hole, you want to put a star in it. And we also have some exceptions. Those exceptions are basically of two types. One is the legislation. That means that if we need to provide data according to some legislation, we need to use the metadata profile that legislations oblige us to use, which may be the DCAT API for the open data or the high-value datasets. Or another exception is that if we want to cite the scientific data, so we should use the data site profile. In the presentation shape, I found that on this slide there should be something really important. So I think that the important site or important quote is the transform what you need link to the original source. So where is the source? In data site, we can use the related item or related identifier to link to the original metadata, to the metadata of the original resource. In DCAT API, we have a property which is called source metadata, and this is used for the link to the metadata of the original source, which is what we're looking for. And in the ISO, we apparently do not need something like that. So the output is that metadata are like cheese. Everybody needs it, and it have holes in it. Basically, holes in the mapping. So this is everything from my side, and I thank you for your attention.